Hi, Paul with Diode Dynamics, talking about optical systems in LED lighting. Now, when you look at any LED light on the market, it's going to have many things in common with other lights. We start with our LED circuit board, which is going to generate light, and it goes in the housing, which keeps it sealed and gets rid of heat. Then we have a wire connector or an actual wire coming out to make sure it gets power. Now, even though these might all look different, those do basically the same things. They serve the same functions. The biggest differentiating factor between different lights is going to be the optical system each light uses. This is because there's a couple major types and designs of optical systems on the market that are going to accomplish similar but different things. Each one will have pros and cons, and that's what we're going to dig into today. Now, the purpose of any optical system is going to be to collect as much light as we can from the light source, in this case LEDs, and direct it out of the housing and to the road ahead or off-road. How much light we're generating versus actually getting onto our target is going to be our optical system efficiency. And again, this is why it's so important to get the design of the optics right when you're looking at any light. We need to make sure the light's focused to illuminate what we're actually trying to see. If we have a light shining up into the sky or directly in front of the vehicle, we're going to blow out our vision, especially in dusty or foggy conditions, so that we won't be able to actually see down a road. Our eyes will adjust to that bright light right in front of us instead of the target down the road ahead like we're trying to see. This is why it's usually not a good idea to use fog lights at high speeds. You want to shine light down the road, not illuminating right in front of you, so your eyes can properly adjust. Basically, we want to collect and shine as much light out of the housing as possible while still avoiding glare or stray light, illuminating only what we want to see as the target. Different brands have different strategies to accomplish this, and they'll select different optical systems or come up with their own to accomplish that goal. At Diode Dynamics, we're well known for our TIR, or total internal reflection technology, but there's many different technologies on the market, and actually we use reflectors and projector style optics in other products we make. Again, there's pros and cons of each, and that's what we'll get into today. Now, the first and most basic style of optical system is going to be our forward-facing reflector. This has been around for over a century, and it's because it's very simple, cost-effective, and it works to simply shine light directly out of a housing. These are still used in the lowest cost types of pod available you'll find on eBay and Amazon, that sort of thing. Again, because it's very cost-effective and it works. An LED will be in the center, and the reflector will be all the way around it, so all the light can shine out. That said, there's a huge drawback of forward-facing reflectors like this. Light coming out the sides of the chip is going to hit that reflector and shine straight out. But light coming straight out the top of the LED is not going to be focused at all. For this reason, you can always see a big circle of unfocused light and then the actual focused light in the center of the pattern. That bigger circle is light that's literally not getting focused in any way. You can improve this by making the reflector much deeper or larger, as you can see in more of the name brand type products, but you're still shining a lot of light directly into the foreground or up into the sky. This can become a huge problem in dusty and foggy conditions because you're actually lighting up the dust right in front of your vision and your eyes. That's why fog lights are mounted so low on the vehicle. You want to shine light underneath that, not light up the dust right in front of you. For this reason, you'll never see this type of forward-facing reflector used in an automotive application these days. It's just too important to avoid glare so we can see what we need to. You'll only see them in stadium lights, flashlights, and some off-road lights. In the automotive world, there are ways to minimize this glare. Again, it's caused by the light shining directly out and not hitting the reflector. So one easy way to fix this is to use bulbs with caps on them. That cap prevents light shining directly forward, therefore it can be used in a fog light without causing glare to other drivers. The reflector still offers benefits of low cost though, and for that reason, automotive designers have shifted to a newer style, which you might call a half-bowl style reflector. These half-bowl reflectors are just what they sound like, a half reflector. And to enable that, the LED is going to shine directly down or directly up into only one half of a reflector. Since the LED isn't shining directly forward, we don't get nearly as much glare, and we still get a really efficient output. A lot of designs will have little blockers at the top or bottom to prevent stray light from shining out of that LED even more. And that provides us with a nice cutoff without a glare, so you'll see these in a lot of factory fog light applications these days. There are some off-road pods on the market that make use of this technology as well. The next major type of optic to go over is our projector style lens. This is also known as solid optic, and it's basically any style of lens where the lens totally covers the LED source. There can be a lot of different geometries to accomplish different things, but the one thing they have in common is that we're going to be really limiting glare. Because all of the light has to shine through that lens, we can control it much better. Now, this can be applied from our more economical ones that are just plain circles, all the way up to our really sophisticated lenses with toroid structures and features to enable really sharp cutoff lines, like you see here in our Diode Dynamics Elite series. Now, the big disadvantage of the projector is that it's not the most efficient system out there. Projectors can't be as efficient as some other options because all the light that's coming to the side of the LED is no longer captured. We're trying to shine light from the LED straight ahead into the lens, and any of the light to the sides is simply lost and wasted in that housing. Still, the projector lens does have its benefits, and it could be the best choice when the appearance of the beam pattern or a sharp cutoff line and limiting glare is more important than optical efficiency. This is why we used it in our Elite series lens and why it's used in a lot of other fog light options, even ones from China that are on the market today. Now, just to recap so far, the reflector allows us to shine a lot of light straight out, but only the light to the sides of the chip is getting focused properly. The projector allows us to shine light straight ahead and focus it, however, we're losing light to the sides. So some engineers have come up with ways to basically combine the two, trying to get the best of both worlds, collecting as much light as we can with the reflector, but focusing it with projector. This is actually exactly what projectors are in a lot of low beam and high beam vehicles on the road today. It's a reflector bowl that then has a projector lens in front to better focus the light that's captured. And even in the off-road world, a couple companies have made a name for themselves by coming up with really innovative technologies, which they call hybrid systems, where the optic itself will be designed into a reflector of sorts to capture light and focus it ahead, and then a projector lens on top of that to focus as much light as possible to the road. This is iterated in a couple different ways, but basically it's a combination of reflector and projector, really innovative. The downside here is it can be more expensive, and we still have the same losses. We're absorbing some of the light in reflectors, and we're losing light with transmission, as well as that outer lens. Generally, the more complex system becomes, the more small losses we're gonna have through that, resulting in good performance, but still not the most efficiency possible. Now finally, that brings us to what you probably know is our favorite type of optic here at Diode Dynamics, the TIR, or Total Internal Reflection Optic. Now, this is not a brand new optic by any means, but it's much newer than the other optics on the table. And a big reason for that is the complexity and cost of design and production. TIRs have been around for quite a while in a much more generic format, like these you might find on a forklift. They're all molded as one piece and they're quite small. The thickness of the plastic material really controls the cost of production, so you'll see a lot of these in tiny little circles. This also limits the efficiency and how much light can be captured from the LED source, especially because 10 years ago, LEDs were much bigger than they are today. Now the TIR relies on something called a critical angle to basically bend and shape the light through two independent surfaces. The light shining straight out of the LED will go through the center lens portion, and the light going to the sides will basically shine in a reflector of sorts. But the important thing is it's all collected in a single component, meaning our losses are limited to just the transmission loss going through the material itself. It can be very highly efficient, much more efficient than any other optical system in terms of getting light to our intended target. The TIR allows us to shine in extremely intense focused patterns with limited glare and high efficiency. It's really the best of both worlds. Since we're collecting and focusing all the light, we can then shine it exactly where we want to, whether that's a really wide spread light or a highly focused spotlight. We've also eliminated the outer lens from the lamp by using that single optic. It really is amazing. The simplicity is what makes it so efficient. Every exterior lens, whether it's on a headlight or one of these other off-road lights, is going to cut down output by about 10% just from light going through and bouncing through that extra lens. Again, with the Diode Dynamics technology, we've eliminated that step, leading to the best efficiency possible. Now, we've heard some claims that TIRs just can't make a smooth or blended pattern that's useful for driving. And that's certainly true with just the basic TIR lens. That TIR, the whole purpose is to shine light really focused in a forward direction, and that allows us to make things like spotlights. They're going to shine way further than anything else possible. Our SS3 Sport entry-level pod is going to shine over 1,000 feet at 1/4 lux, which pales in comparison, 50% more than even a laser pod from our competitors using the reflector technology. Laser technology is very promising, but reflectors simply aren't efficient enough if you want to focus the light far down road. But that doesn't mean that TIRs can't be smooth or blended. After we focus all the light really tight, all that's needed is a little bit of extra texture on our optics to smooth it out or create whatever beam pattern we'd like. When you have light that's efficiently captured and focused, it's up to the optical engineer to make as smooth or spread or as wide pattern as they'd like. In contrast, a forward reflector design is always going to have extra glare because it's literally not focusing a lot of the light. A lot of it just shines straight out ahead. Whether you call that blending or glare is in the eye of the beholder. As you can see, there's a lot of types of optical systems on the market, each with their pros and cons. Forward-facing reflectors are going to be very low cost and shine all of the light out. However, a lot of it's not focused and instead becomes glare. Projectors are going to capture all the light facing forward, allowing you to create really nice patterns with sharp cutoffs. However, they're not the most efficient. TIRs are a great balance of efficiency with how simple the system is. However, it requires higher design, engineering, and production costs. When it comes to designing a new lamp, optical engineers are going to look at the pros and cons of each technology to choose the best one for their needs, whether that's high efficiency, a really sharp cutoff, or just shining as much light out in all directions with cost in mind as well. I hope you'll do the same when it comes time to get the next light for your setup. Evaluate what type of light you need, where you need to shine light, and the pros and cons of each optic, and actually choose a light based on which optic is being used. You can learn more at diodedynamics.com, or please feel free to reach out to us to discuss your next lighting need. Thanks for watching.